Hello and welcome to a tutorial on classes and objects in Java. If you've been taking my class or just following along with these, we are now at the the end of the beginning of you being a computer programmer. After this lesson, you will know almost everything there is to know about the basic building blocks of computer programming. Now, there's a lot more you need to know. So you're at the end of the beginning, and yet from here, you can go on and pick up stuff pretty quickly if you understand how all this works. So to begin with, just to review sort of the coding format and how it kind of works is you start with variables, right? You start with variables, and variables are your basic building block of computer programming. You set variables by defining certain data and naming it certain things. And then you, if you remember, you build branches. Off of that, you have two types of branches. You have conditional branches, which will only run if the condition is true, and then you have a loop which will only run if the condition is true, but then it will keep running until that condition is no longer true. And remember, you have for loops and while loops, then you have that special little do while loop, and so all kinds of fun there. And then you build branches. You use branches to build what we talked about last time, which is functions, right? And functions have a name and they have parameters, and then what to do with those parameters. Commands telling you what to do with those parameters. And now we're getting to the end of it. Now, the last thing we need to know is classes and objects. And so classes and objects are made of functions, which are made of branches, which are made of variables, right? This is all just ways to group your coding into repeatable chunks so that you don't have to keep writing the same code over and over and over again, or even copying and paste it. You're just grouping your code into manageable chunks so that you can, so that similar code runs similarly. So with that said, let's talk about classes and objects really quickly, really briefly. Spend the next few minutes doing that. So classes are probably what you think they are. They are groupings of things that are alike. And so I think about in the animal world, which your assignment this week, if you're in my class, is on the animal world. In your animal world, you have different classes, right? And then classes are made up of species, and species are made up of breeds. And so if you took high school biology, you know that. Computer coding is the same way. You have classes of things, and then even you have subclasses, which we're going to talk about next time, and then you have objects in those classes. And so to give you an example, I teach for LCA, and LCA has a class which we could say is people. Right? There is a people class, and then there are two types of people. Well, there are 3 or 4 types of people at LCA. There's students, right? Then there's parents, right? Then there's faculty, and then there's staff members, sort of support staff member. That's your janitors, your secretaries, people like that. We have an international liaison at LCA, and we have coaches, right? And coaches are kind of a weird thing because they're both faculty and staff, but not all of us teach on the faculty. So you have that, and then you have administration, right? Administration is staff, but it's a higher level staff. That's your principals, right? And the heads of the school. And then we even have board members. We have a board, right? And so we have people, but we have all these groupings, right? Of all these different types of people. And so students have a class schedule, and staff has a class schedule. Faculty has a class schedule, but the parents don't, the staff doesn't, administration doesn't, the board doesn't, right? But all these people have names, right? All these people have social security numbers. All these people, except for the board and the parents, get a paycheck, and students don't either. So yeah, so if we're creating a computer program to keep track of all this, we'll have a class called a class called people, and then we'll have subclasses, which once again we're going to talk about next week, that fall under that. It inherits the people, and so there's things these 6 groupings of people have in common, but then there's things they don't have in common. And then you may even have subclasses of subclasses, right? So you may even have, students, you have freshmen, you have all grades, right? And so you have first grader, preschool all the way up to seniors. You have nationalities at LCA. That might be a subclass, is what country you're from. Faculty has subclasses. There's art faculty, and there's science faculty, and there's English faculty, and there's math faculty. Staff, you have your janitors, you have your secretaries, right? Administration, you have your principals, and you have your other people, you know, and so, but then eventually you get down to objects, and objects is also called an instance of a class. And so an object might be Mike, the ninth grader, right? Mike, the ninth grade student. That might be the instance of a class. And so Mike, the ninth grade student, can do everything that all the other ninth grade students can do. There's very little that's special about him. So instead of writing tons of code for all the ninth grade students, we just write our classes, and then Mike can do anything else that these classes of code can do. So let me give you one more example, and then we'll get to the actual coding. Let me give you an example actually from the computer world, because that's going to help you sort of jump from talking about people at LCA to talking about computer programming. I want you to think of a typical video game. Right? So you have a video game. Maybe we have a class of enemies, right? These are antagonists, people that are going to fight the main character of your video game, right? And let's, so I'm going to go ahead and take sort of the old game StarCraft as my example. I don't know, not many of you have probably played that game, but you'll be able to understand as I talk. So you have a class enemy. So you might have some subclasses, right? You might have flying enemies, and you might have ground enemies, right? And then you might even, with StarCraft, you have ground enemies that can shoot flying enemies, right? And then you have flying enemies that can only shoot flying enemies, right? And so you have all these subclasses, right? And in StarCraft, you actually have a subclass above that. We might call this subclass 1. You actually have 3 races you can be. You have the Terran, then you have the Zerg, then you have the Protoss, right? And each of those have different things about them. All Terrans have just hit points. That's all they have. Zerg have hit points, but they can heal over time. Protoss have hit points and shield. So any Protoss unit is going to have a shield sort of attribute. So instead of programming that for each and every unit, you write the Protoss class, and then you know every instance of that class can have that. So then you might have the subclass 2, right, of all these enemies, and then you have your objects at the bottom, and that is like a Zergling. Is an instance of that class, right? A Zergling is a ground Zerg enemy that has very low HP but can attack very fast. And so you kill it very quickly, but it does a lot of damage before you can kill it, right? So that's our Zergling, and it is a ground enemy that can only attack ground. Only attack ground, and it's Zerg. Right? And it's an enemy. So it can do everything enemies can do. It can never do everything Zerg can do. It can do everything ground enemies that can only attack ground can do, but it has its own attack pattern. It has its own amount of hit points that it has, and its attack speed and how much attack that damage that does. So you see how this works. That instead of just writing code for every single little Zergling that appears in StarCraft, which you know that you can have 400 of them at one time, like one player can control 400 of them at one time if you really wanted to. Then instead of that, the players just said, we created these classes, and then we just gave the Zergling permission to do what everything in its sort of tree would do. Isn't that cool? So with that said, if you want to pause and sort of take those notes, you can. But I'm going to delete them real quick, and now we could get to computer coding. So as you notice, and as you've probably noticed if we've gotten this far, Java is a class-based system. It's also called an object-oriented programming. And so because Java is object-oriented, it means that Java is set up so that you actually can't do anything outside of a class. Everything happens inside classes in Java, and Java makes it nice because your classes are also your file names. So we created class main, and over here we have main.java. And then every file, as you know, opens and ends with these curly brackets. So everything in between this is a part of the main class of our computer program. Then you know every class has its main arguments right here. These are the arguments of the main class, and they're going to be in strings. You probably recognize now that that's a function. You probably didn't know that a couple weeks ago. We talked about functions last time, but this is a function right here. And so it's named main, and its parameters are string arguments. So it has two parameters, string arguments. And then we say, and then you notice this is another function right here, system.out.println. And you're going to recognize by the end of this lesson that these dots are identifying classes. So system is the name of the object, and then out print line are the classes that are above it. Isn't that cool? And then the parameter of the function is hello world. And so system is calling the out print line function, and then the parameter is hello world, and when we run it, it prints out hello world. Isn't that cool? Well, we're going to go ahead and map out LCA. So we're going to create a new file. So you're going to want to click this button right here, click new file, and this file name has to be the name of our class. And so we're going to name it people, capital P, .java. By the way, in standard coding procedure to capitalize your classes. Classes are capitalized, functions and variables are not capitalized. So there we go, people.java. Now we have a blank line. And we want to define our class. We're going to say public. We're going to talk more about that next week, but public gives permission to all the other classes to use this class. And so it's giving permission for everything else. If we had 10 classes right here, the public would say every class can call an object and create an object in this class. And then remember what I said, it has to be the exact same. People.java, and then every class opens with a curly bracket. I'm going to do something that we should have been doing all along, and that's I'm going to add a comment next to my curly bracket here before I enter it down, and I'm going to say what that is ending, which you should do that too. This ends the class. Because this is going to get lost. As we add a bunch of stuff to our class, it's going to end up clear at the bottom of the file, and so we want to make sure that we know what that's doing so we don't accidentally delete it. So I just put ends class. Then remember that the functions and the attributes of a class go above the arguments. And so right here, we want to copy line 2, just copy line 2, public stack void main string args, and we're going to throw this all the way down there, but we're not going to name it main string args. We're going to name it lowercase people string args because it's the main arguments of the people class. So we're just going to put that there. Once again, notice we did not copy our ending thing, so we have to end the arguments, and then right next to it, we're going to say ends arguments. So that once again, we could keep track of what that's ending when it ends up at the bottom of our file. So that helps you know what these are doing. And then the attributes and the functions of the class are defined above the arguments like anything else, right? And so with that said, let's talk about what attributes are real quick. Attributes are the variables that describe the object. So think of me where this is a people class. I have a name. And so that's a variable. I have one name. It is Kevin. Kevin is not something I do. It's something I am. I have brown eyes. That would be an attribute. I'm tall. I'm 6'2", right? That is an attribute. And so attributes are things that the class is, things that define the object, but not that the object does. Then we have functions, which is things the object does. Things the object actually is doing, actions it is performing. And so go back to the Zergling from StarCraft. The Zergling has an image associated with it. That's an attribute. So that every time that Zergling is created, the little critter appears and they all look the same. Function is what it does. So the Zergling attacks. So we have to write a function to get the Zergling to attack. Zerglings also defend. And so we have to write a function for when it is being attacked, how much of that attack it's deflecting. And so functions are what the object does. Variables describe the attributes of the class. So how this works is we first define the attributes. Just like the top of any program should be your variables, we are first going to define some attributes. Remember to tab in just so you can keep track of what's beginning where. So let's start with saying, we're going to call it object name. It's actually what we're going to call it. And remember, because it's a variable, we have to define what it is, right? So we created an object name, meaning every object in our class is going to have an object name. So that's the first thing. It's going to have a name. Then we're going to create an age, but that's actually going to be an int. And so an integer age. Your age is a whole number. It's an integer. So every object is going to have an age. Then we're going to have a birthday. Think real quick, what is the birthday going to be? Is it going to be a string, an integer, or what data type is it going to be? It's actually going to be a string, right? So we're going to say object birthday, right? Object age, object birthday, right? And then we'll do just one more for fun. We'll do, oh, what should we do? Let's do hair color, which once again is a string. And we're going to say object hair color. And there we go. So we have created 4 attributes that any object in this class is going to have, right? So now let's see if I did it right, and we'll run it. And if not, I have my little cheat sheet over here. Always a good idea to have your cheat sheet over here. So that's interesting. It didn't like something I did. So we'll see if that fixes as we go. So don't worry about any errors at this point. It's expecting something I haven't done yet. I think I'm getting ahead of myself. So yeah, so those are our variables, right? That are going to do that. So then we're going to create some functions, right? And you remember how to create a function. You give it a name. You give it a name and you give it parameters. But I'm going to introduce to you a very special type of function called an init function, also known as a constructor function. A constructor function is when you create a new instance of that class. It automatically does that. And so you don't have to call this function. Constructor functions, you don't have to call. They run automatically when the object is created. And so we're going to create a constructor function. And you can create constructor functions that either have parameters or don't have parameters. And so yeah, and I'll give you an example of either. So the thing is, if you want to build a constructor function, here's what you have to do. You have to name it exactly what the class name is. So construct functions that are named the class name are constructor functions that will run the minute you create an object in that class. And so we do have to write public void like we did last week, and then we just name it people, capital Y, P, and then just 2 brackets. And remember to add your comment that this ends people function. So you could keep track of this little ending sort of branch here. So it's people, and then in parentheses, we're not going to put anything right now. We're not going to put anything right now. And the arguments are going to be system.out.println, and then we're going to say something like object name plus is, or well, let's do, since we're doing LCA, comes to school, right? So the minute we create an object, it's going to say they came to school. So then up here, and in this case, we don't want to do this, but I'm just giving you an example. Up here, if we want every object to be named the same thing, we're going to just say Betty, right? And then we're going to say object name equals 17, 17-year-old student named Betty. Actually, you don't need quotation marks because it's an int, my bad. We're going to say her birthday is April 4, and then her hair color is going to be brown. She's going to have brown hair. Betty, April 4, brown hair. And then we're going to say she comes to school. Then we're going to delete that because it's going to screw up my program because I didn't comment it out. And then we're going to go up to the main. Go up to the main, and in the main string args, we're going to create a new object. We're going to name object1 equals people. And I think there. Let me double check my my thing there to make sure I did that. So yeah, actually, no, we need to put the class first, which is really weird that we have to do that, and I keep forgetting it. So we have to say people, and then object1 equals new. We are creating a new instance of a person, of people. And so, so now let's see if it, oh, nope, it's not going to like us because I did that. Let me double check too that I did. So it's just public people. So public class people, public people. Right up here, this actually needs to be just public people. Run. And so 6 errors. Oh, I forgot to say class. Add class right here. That is a ridiculously stupid mistake that I made. So I really do enjoy, I know it's weird, but I do enjoy making mistakes so I can show you guys I'm learning too and I make mistakes too, and it also teaches you to remain calm. Learn how to, I totally forgot to say class. I wonder if that's going to fix all my errors. So still doesn't like us. Oh, just one error. So where did I make an error? Oh, I know right where it is. It's right there. Yep, that's right where it is. So that's why I didn't like us so earlier. So anyway, it's public class people. That's a dumb mistake to make. And then public people down there. And notice it says Betty comes to school because the minute we created Betty right here, notice we didn't even name her Betty. We just named her object 1, but her attribute is that her name is Betty. The minute we created her, it says Betty comes to school. But watch what happens. If I go up here and I want to add a new person, let's actually name this Benny equals new people. Do you see that? Semicolon. Now it's going to say it twice, unless I made a mistake, which I may have. So it's going to say, wait for it. Yep, Betty comes to school, Betty comes to school. Well, the second one was Benny. So once again, we can do that. And there are attributes you want every single person in your class to have. Go ahead and define them up here. But if you don't want to do that, you just erase the values, leave them blank. You create the variable, but you don't put anything in it. And then down here, you add those attributes. So name, age, birthday, and hair color. You add those attributes to your constructor function. You see that? And now, in our function, we have to define those attributes individually. And how we do that is we just say object name equals name. You see that? Object age equals age. This is kind of tedious, but once again, you only have to do it once, and you're going to create hundreds of instances of stuff in your program, right? Object birthday equals birthday. And object hair color equals hair color. There we go. Then we're going to print it out. We're going to print object name comes to school. And we're going to say object name. We're going to concatenate it and say is, and then plus age, plus years old, and has hair color. It's actually, these all need to be object, my bad. Object age, object hair color. Hair color plus hair. There we go. There we go. So, and then I guess we can print the birthday out too. Object name plus has. Remember, if we want to cancel something out, we use the /. Actually, we use the /. Maybe we should use the /, but for some reason that's not color coding right, but we'll see if it works. Object name, object names, birthday is, yep, it did, okay, is, and then object birthday. Yep, so add a space there. So now, every single time we create a new object, it's going to say their name, whatever we named them comes to school, whatever we named them is this year's old and has this hair color and tells their birthday. Isn't that cool? And don't forget your semicolons, which I'm forgetting a lot of those lately. It's because I've been teaching Python, which doesn't use them. So there we go. Now, when we bounce over here and we create Betty, we're just going to name her Betty equals a new person, people. In the parentheses, we're going to add all those things. Her name's Betty. And I can't remember the order. Remember, they have to be in order. So it's name, age, birthday, hair color. They have to be the exact same order here. So she's 17, I think we said, and we don't need quotes around that one. And I think her birthday was next. Yep. So April 4th, right? And her hair color was brown, right? Then we're going to create Benny, and his name is Benny. And he's 15 years old, and his birthday is October 30th, right, the day before Halloween. Lucky him, a lot of candy for his birthday. And his hair color is blonde. So there we go. Now, when we run it, unless I made a mistake, which I'm sure I probably did. Yep, I did. it doesn't like something that we did. I forgot the data type. So string name, int age, string birthday, and string hair color. So once again, if you're naming the variable in your function, you gotta say what data type that is. So tedious, I know, but that's it. So there we go. Betty comes to school. She's 17 years old, has brown hair, and her birthday is April 4th. Benny comes to school. He's 15-year-old, has blonde hair, and Benny's birthday is October 30th. So there we go. That's a constructor function, meaning we construct it the minute it constructs the minute we make a new instance of that person. So this function right here, ran the minute we created Betty and the minute we created Benny. Now, we don't have to have constructor functions, right? We can create functions like we did last time. So we can create a public function called go to class, right? And we have to use this parameter. This parameter means this means that, wonderful punny there, this is what this means. This means right here, this means that the object itself is able to do things in the function. It's a parameter that's able to perform things in the function, which you want. Remember, let's close out this ends go to class function, just so we can keep track of our ending branches right here. Enter it down, and we're going to say, that when this function is called, we're going to system.out.println, and we're going to say object name plus goes to class. Do you see that? Semicolon. And then we'll just create one more for fun. Right down here, so because this object, whatever object is running this function, is a parameter in the class, the word this is giving this function permission to access all these attributes up here. All these attributes we defined up here, and print them out and use them to do things, right? So public go to class, and then we'll create one more. We'll create public skips with this, which you should never do, by the way. Don't skip class. And ends skips function, right? That's what we're ending there. And then here we're going to out.println, and we're going to say object name plus skips class, right? So there you go. So then over here in our main system args on our main file, we can call these functions just by simply, it's very easy. In fact, I have it right over here. We just do Larry dot whatever the function name is. So we say Benny dot go to class. And because this is a parameter, you don't need to put anything in the parentheses. If this is a parameter, you just skip that in the parentheses, and the computer does that. Benny go to class, and then we say Betty dot skips. There we go. Now when we run it, it will print off all the init stuff. Didn't like something I did. What didn't it like? Give me a second to double check that. Oh, you have to say this dot object name. Once again, man, my brain's dead today. So in our parameter over here, follow along, we don't say object name, we have to say this dot object name. We have to refer to whose object name it does, is what we have to do. And so that was my bad. So print it again. Here we go, run it again. Once again, if you're having trouble with the console down here, hit this X button. It seems to fix things. Oh, give me a second to problem solve that. Oh, we actually don't need this in line 23. Well, I put it there so I could teach you what it does anyway. So we actually don't need this up here. So now we'll see if it runs. Nope, still doesn't like us. Interesting. Let me look at my cheat sheet again. Yeah, it's exactly the same. Go to class and then goes to chapel, right? This is what I created over here. Oh, I didn't say this object name there, but I don't think that did anything wrong. So Well, you can see this one runs. I didn't say this dot object name on the other ones. I'm wondering if that throws it off. Let's look at it. Up here, let's do this dot. Let's add this, because that's what I did last time, and that may have been our problem. Because you do have to specify which object is, like whose object age, whose object hair color, things like that. And up here, I didn't do it. So there we go. Now let's try it again. Give it a second. Still does not like us. Did I? I didn't. Yeah, I put that there. Over here. In the main, it's in the main string args. And so Larry.chapel, Julia.goes to school. So over here, we created 2 new people, and then we said Benny go to class, Betty.skips. So look, it's exactly the same. Go to figure, right? Oh, I put those in the people function. Huh. See that? Even I kind of mess up. That's why it is important to add a comment to the end of your little curly brackets so you can debug your code like that. So there you go. You learned about a little bit. And these have to say void, which I knew. So this is computer programming, everybody. You just sort of learn how it works. So you do have to void. We'll talk about what void means next time. But there you go. Benny goes to class. Betty skips class. There you go. And I'll teach you one more quick thing. If you have put up with my sort of coding mistakes and debugging, I'll teach you one more cool thing. Let's create up here. We're going to create another variable to check to see if Betty has skipped class or Benny has skipped class. And we're going to say skips class, but we're going to say equals false. And that's going to be a Boolean, which means it's just true or false, right? And then at the end of skips, we are going to check to see if skips, to see if they have skipped or not. We're going to add a little switch there. This is called a switch or a Boolean. And we're going to say this dot, right? This person skips class now equals true. Do you see that? So we're going to change it to true. Let's see if I made a mistake there, just for fun. Doesn't look, oh, dang it, it does. Maybe it's not true. What should it be? Let's do another way around the Boolean. We'll just do an int, just so I can show you what I'm doing here. And we're going to make it 0, which means that they haven't done it. We're going to do down here in the skips, this skip class, we're going to turn it to 1 is what we're going to turn it to. So whoever skips class, there's going to be a switch flip that notes they skipped class. And then we're going to create a new function underneath that. And this is going to be public void. And we're going to say detention. And I'm not going to put an end thing there. And this one closes the detention function. So we're going to create a detention function. And it's just going to be simple if, right? This dot skips class equals 1, which means if it's true, then we're going to system.out.println this dot object name. Oh, sorry. This dot object name plus has detention. Bam. And then we're going to create an else branch. Right, and this ends else branch. This ends else branch, and we're going to say system.out.println this dot object name plus does not have detention. There we go. Now over here, we're going to check to see if Benny has detention or Betty has detention. So we're going to run Betty detention. Right? And we're going to run Betty.detention. We're going to see if they have detention. So there we go. When we run it, I'm sure I probably made another mistake. That's how this has gone. But nope, it didn't. So Benny does not have detention because Benny went to class. Betty has detention because Betty skipped. You see how that works? So, so now we could build conditional branching off of what's true about each object, right? Which is a lot of fun. So, so there you have it. There is a long tutorial on objects and classes and how they work. I hope you enjoyed it. I hope this is helping things like switches click on for you about how computer coding works, how you can divide your code up and so you don't have a bunch of code everywhere, right? So yeah, so enjoy it. I'm basically expecting you to do exactly what we just did, but with animals, if you're in my class for the assignment. If you're not in my class and you just learned a bunch about classes and objects, I hope you enjoyed it. I'm sorry about having to do those bugs for you, but I also hope it taught you something about how to just pay attention and debug your code and why it's good to have another file open like this guy over here where it did work so you can compare between what worked and what didn't. Wonderfully helpful practice I was trying to teach you there. So good luck. Let me know how it goes. Thanks.